Hey guys, so I'm making this video today because I feel like some people had left class feeling more confused from when they entered class today, and I just want to clear up some of those misconceptions and confusions before the test tomorrow. So what I'm going to do is I'm just going to go over the graphing trig functions take-home quiz that you guys turned in on Monday or Tuesday, and I'm just going to talk about a couple of these things and go over the how to find these amplitude period phase shifts and whatever. So if you at any time want to just skip forward to get to the stuff that you don't know how to do, that works. If you need to pause or rewind, that also works during this. I'm going to try to get to all of these problems in kind of a relatively quick manner, just so that you have something to reference tonight while you guys are studying, and it'll hopefully be kind of this and comprehensive review for you. Before we start this though, I just want to talk about what sine and cosine are and the cosecant and secant. So we know a relationship between all those things. They all have a period of 2 pi. They're all periodic functions, which means they repeat. And we have certain things like a parent function that affects that. So for cosine, our parent function looks something like this. And we have these values on the outside that affect our amplitude and so on. So for this case, all we have is this -2, and that changes the amplitude, how high our function goes up. So it's a reflection, since we have a negative, and an amplitude of 2. But our period would be right whatever's in front of that x, which is the same this time. It's just 2 pi over 1 in this case, which is 2 pi. We don't have a phase shift because we don't have anything inside of the parentheses, and we don't have a vertical shift either because we don't have a +5 at the end or whatever. So that means that when we're doing our 2 pi, we have pi over 2 segments. Remember, we took that and we divided it by 4. Which means that each part of our critical value, we're going to be increasing that by pi over 2. And so that just gives our standard parent function graph. The only difference is when we actually graph this time, we have an amplitude of 2 and we have a reflection. So instead of starting up at +2 or up at 1 for our parent function, we're going to start down here at -2. Our second critical value is pi over 2, up to 2 for our critical value of pi, and then back down following our cosine graph. So it looks something like that. And it also says to state the range of all these. Our range of our cosine and sine graph are between 2 values. And in this case, it goes from -2 to +2. Okay, this one's really similar. We still have that amplitude up front that changes how far our graph is going up and down. We don't have reflection because it's not negative. Our period, in this case, we do have something that affects that. We have this b value as pi in this case. So 2 pi over pi gives our period of 2, which means that we have half segments. We have 1/2 segments. And again, we don't have a phase shift, and we don't have a vertical shift. So when we graph this and we're labeling our x-axis, we're increasing our values by 1/2, which in fact is the same thing that we have over here, except we have pi over 2 instead of like 1 over 2. Okay, and for sine, we start at 0. Our next critical value goes up to 2 in this case, since it's an amplitude of 2, back down to 0, down to -2, and back up to 2. To create our function, sine function, looks something like this. And again, our range for our sine and cosine graph are between 2 values. And in this case, we're looking at just like our amplitude, that changes our range. We're going down to -2 and up to 2. So our range is -2 to 2. Okay, so we're sticking with our sine graph here. We'll find all of our important values. Our amplitude in this case again is 2. It's the value in front of that sign. Our period this is our b value, so 2 pi over 3 over 4, which means it's 2 pi over 1 times 4 over 3, which is 8 pi over 3 in our case. And if we're dividing by 2 or by 4 to find our equal segments, it's going to be 8 pi over 12, which is, if we divide this by 4, we get 2 pi. If we divide this by 4, we get 3. So our segments are 2 pi over 3 segments. This is our period, but these are the segments that we're going to increase by. Again, we don't have any phase shift or vertical shift. So I'm going to be increasing my x-axis by 2 pi over 3. So the first one is 2 pi over 3, since I'm starting like from 0 and this is our first critical value. And then 4 pi over 3, 6 pi over 3, which is 2 pi. And 8 pi over 3 to add another 2 pi over 3 onto that. Again, my amplitude is 2, so at 0, my critical value is 0, up to 2, back down to 0, down to -2, and back up to 2. And again, my range is -2 to 2, because that's all that's affecting it is my amplitude. I'm not going up, I'm not having a new baseline, so this is all I have to do for that. Okay, so we're going to do the same thing over here. For this one, we're dealing with a cosine function. Our amplitude is 3, and we have a reflection. Our period is, we can't actually find our period yet because we have this 2 that needs to get factored out. So when we divide everything by 2, we get pi over 4 as our, which will turn into our phase shift. But this is now our b value. So our period is 2 pi over 2, which is pi, which means that we're going to have pi over 4 segments. Okay, just taking that value over 4, same as always. Our phase shift is on the inside here. We're going to the right since it's negative, pi over 4 units. Our vertical shift appears right out here. That's up 3. So when we draw our graph, the first thing I'm going to do is deal with my vertical shift, because this is going to become my new baseline. And this part's easy since our phase shift actually matches what we're going to be increasing by each time. We can just start our graph or x-axis by labeling that. So pi over 4, 2 pi over 4, which is pi over 2, 3 pi over 4, can't reduce, so we'll leave it like that. 4 pi over 4 is pi, and 5 pi over 4. 1, 2, 3, 4, 5 critical values. Okay, so for cosine, we would normally start at using our amplitude going up that value and then going down like this, but we have a reflection, so, and our amplitude's 3, so from our baseline we're going to be going down 3 units, so we're actually on the x-axis here. At pi over 2, we're at our baseline, it's like our second critical value. At 3 pi over 3, we're going up to our up 3 from our baseline, so we're at 6, down to 0, our baseline, and then down 3 from our baseline, which is actually on our x-axis. So my cosine function looks like that. So we have two things that are affecting our range. First off, we have this vertical shift that we have, which is our new baseline. And then we have our amplitude. So if we didn't have this baseline, this new vertical shift, our range would be from -3 to 3. But that pushes that up 3 units. So it's -3 plus 3, which is 0. And then 3 plus 3, which is 6. And you can see that from our graph. We go down to our x-axis of 0 and we go up. Our highest value is at 6. And again, you can find that from our vertical shift. Taking our vertical shift 3 and subtracting 3 of our amplitude, since we're going up and down from there, and adding 3 on from our amplitude. Okay, so cosecant and secant are a little bit different, but we're treating them the same way. So since secant is with cosine, we're going to first graph this function, and then we'll add on the important stuff that we need to actually finish it off with for secant. So I'm going to find all my important information, my amplitude, my period, my phase shift, and my vertical shift. My amplitude in this case is 1, so I don't have anything out there. My B value is 3, so my period is 2 pi over 3, which means that when I find my segments, it's 2 pi over 12, dividing by 4, multiplying the denominator by 4, which is pi over 6 segments. My phase shift, we have a minus here, so that means we're moving to the right, pi over 6 units. And our vertical shift is down 2, since we have a negative 2 on the outside. So again, the first thing I'm going to take care of is draw my new baseline at negative 2. And then I'll start labeling my x-axis. Again, we have that same situation where our segments actually match our phase shift, so that's kind of nice. We don't have to do any conversions. So I'll start labeling those in pi over 6 segments. So pi over 6, 2 pi over 6, which is pi over 3. Oh, yeah, pi over 3. 3 pi over 6, which is pi over 2. 4 pi over 6, which is 2 pi over 3, and 5 pi over 6. And I think that gives you 1, 2, 3, 4, 5 critical values. So this is our new baseline. We're graphing cosine, so same as above. We're dealing with this shape, although it's a normal cosine graph, so we're going to be looking like this since we don't have a reflection. We have an amplitude of 1, so in our first critical value here, we're going to go up 1 unit from our baseline. Pi over 3 is our second one, so we're at our baseline. Pi over 2 is our third critical value, so we're going down 1 unit from our baseline, back up on our baseline, and then up 1 more at negative 1. So our cosine graph looks like this. But we're actually not finding cosine, right? We're finding cosecant, which is 1 over cosine, and we have problems with 1 over cosine because we can have cosine be 0, and in fact it does equal 0 in these values on our baseline, although it's not like actually 0 in our values since we have that vertical shift and we have this phase shift. This is going to produce something that's 0, which is a problem. So at these values we have these asymptotes. Okay, and so from our asymptotes, then we look at our maximum and minimum values. So we have a maximum here, which means we're going to draw our U going up. We have a minimum here, drawing our U going down. Maximum again, U going up. And this actually, the stuff in black, is actually my secant graph, not the stuff before. And my range is actually going to be the opposite of what the cosine. So cosine would be negative 3 to negative 1. Secant then is the opposite. So we're going from negative infinity up to negative 1. We stop. We start again at, at negative 3. We start again at negative 1 and then go to infinity. So again, it's just the opposite. For the cosine range, it would be negative 3 to negative 1. The secant range is everything but those three, that range of values, negative 3 to negative 1. Okay, so cosecant is graphing the same way, except we're going to deal with sine. And again, since we have this stuff inside here, I'm going to have to take out a 1/2. When I divide everything by 1/2, I'm really multiplying by 2. So I'll do that over here. Multiplying by 2, I have 2 pi over 4, which is pi over 2. So that's going to actually be my phase shift inside my parentheses there. And then I'll find all of my critical values, or critical pieces of information, I guess, not my critical values really. My amplitude in this case is 2. My period is 2 pi over 1/2. since I'm dealing with this is my b value. Dividing by 1/2 is the same thing as multiplying by 2, so I get a period of 4 pi, which means I'm dealing with pi segments. Dividing that by 4. My phase shift is to the right pi over 2 units, and my vertical shift is going up 3 units. So again, I'm taking care of my vertical shift first. I'm drawing my horizontal new baseline for that. I'm dealing with sine, which means when I actually do draw this, when I figure out my what I'm going to count by and stuff, my sine is going to look like this. Okay, so I have right pi over 2, and I'm dealing with pi segments. So I know that pi over 2 is half of my pi segments. So again, like, you can find your critical values if you want by taking your phase shift and adding pi to that, and you'll get your first or your second critical value. This is number 1. That's going to be 2 pi over 2. Pi plus 2 pi over 2 is 3 pi over 2. And then you could take that and add pi again, which is 2 pi over 2, and you get 5 pi over 2. And so on. So you could keep going with that pattern. I know that every 2 pi over 2 segments that I have, I get my pi, which was what I want. So I'm going to label it that way. So I'll start with pi over 2. This would be 2 pi over 2, so 3 pi over 2, 4 pi over 2, 5 pi over 2, 6 pi over 2, 7 pi over 2, 8 pi over 2, and 9 pi over 2. It's not very even. But these are my 5 critical values that I'm dealing with, and this is a unit of pi. Like, if I find the distance between pi over 2 and 3 pi over 2, I get pi, which is part of what I want there. Okay, and then I'll finish up here. So I'm starting at my baseline for sine. That would be the 0 value. My amplitude is 2, so from my baseline I'm going up 2 units, back down to my baseline for my next critical value, which is there. Down to 2 from my baseline, so down to 1 at 7 pi over 2, and then at 9 pi over 2, I'm back up at my baseline. So I have those 3 baseline values. So my sine looks something like this. And just like secant, we have problems when the cosine and secant, when that was in the denominator of 0. Same thing for cosecant. We have problems when sine is 0. So we have these asymptotes that appear at pi over 2, 5 pi over 2, and 9 pi over 2. And my cosecant graph then would be the u's around those, my maximum value and my minimum value, dealing with just those values rather than the stuff that's in between. So my range, again, I'm going from negative infinity up to my lowest point, which is at 1. And then I'm starting at my highest point here, or my maximum value for that was at 5, and then going up to infinity. Okay. From the next part, we're dealing with cotangent, tangent, and last one's tangent as well. So these are actually a little bit different. Cotangent, my normal parent function graph, and I know I talked about this in class a little bit, my normal parent function graph for cotangent looks like this. And I have asymptotes at 0 and at pi, because cotangent and tangent have a period of pi. So when we find our actual period, it'll be like pi over b rather than 2 pi over b. And cotangent, we have these asymptotes at 0 and pi. And for tangent, our parent function looks like this, and we actually have asymptotes at negative pi over 2 and pi over 2. So it actually like surrounds our tangent on either side equally around our y-axis. And this actually affects it when we do our phase shifts and that kind of stuff. But for cotangent, we treat it pretty much the same. we're dealing with the same kind of ideas when we find our period, our phase shift, and our vertical shift. And we find our critical values the same. We're starting at like the critical value that we had, that 0, when that's going to be our asymptote, and so on. We find all our critical values by finding 5 from that with our even spacing. In this case, my amplitude is 2. I have to pull out that 3. So if I'm dividing everything by 3, I get pi over 6, which means my period in this case, if this is my b value, is pi over 3. And I'm still going to break that into 4 segments, so that's going to 4 equal segments. That's going to be pi over 12. Again, dividing this by 4 would really mean multiplying by 4 in the denominator. Phase shift, I'm going to the right, pi over 6 units. And my vertical shift is going up 1. So again, the first thing I'm going to do is label my new baseline at 1. I'm going to the right pi over 6 units, but I'm dealing with pi over 12 segments. So I'm going to label my x-axis as pi over 12, because I know at 2 pi over 12 I get pi over 6. And 3 pi over 12 is pi over 4. 4 pi over 12 is pi over 3. And 5 pi over 12 can't reduce. And that gives me my 1, 2, 3, 4, 5 critical values. Again, you can do that by saying, okay, well, I'm going to start with my phase shift, I'm going to start with my phase shift. I'm going to add pi over 12, and I'll get my new, this would be my first critical value, so I'll actually need one more. I'll get my new critical value. This is going to be 2 pi over 12, which is 3 pi over 12, which is pi over 4. And that'll be my first critical value that I have. And then I'll add another 12 on to that, pi over 12, which is, I'll start from this one. I'll add another pi over 12, which is 4 pi over 12, which gives me my pi over 3, which is my next critical value. And I add on another pi over 12 where I left off of 4 pi over 12, and I get 5 pi over 12. And then another one would be 6 pi over 12, which is pi over 2. Okay, so this is where I'm starting here, and for my cotangent, this means that this is an asymptote. So I have an asymptote at my first and my 5th critical value, and right in the middle, my 3rd critical value is actually on my line, on my baseline. And remember, cotangent looks like this. So from our first or 2nd critical value, one to the left of this, I'm going to go up 2 units, since my amplitude is 2, from that value. To get my next point. And then my 4th critical value, the one to the right of pi over 3, my middle one, I'm going to go down 2 units since my amplitude is 2. And those will be the values that I'm going to connect in my cotangent graph. My range in this case, since I'm extending in both directions, is negative infinity to infinity. My domain is not this case, but my range is. My domain, I have to exclude some values, and you can kind of check that out in the, I'm going to upload the in-class review that we looked at today, so you can kind of check those out as well. Okay, so that's cotangent. Let's talk about tangent. So my amplitude in this case is 2, but it's a reflection. My period in this case is pi over my b value, which is 3, which means again I'm dealing with pi over 12 segments if I'm dividing that by 4. My phase shift is none. I'm not dealing with that at all. My vertical shift is none. So that means that I'm dealing with my center point here. Since I'm not moving up or down, that's going to be my center, and I'm going to be surrounding on both sides. But in this case, since I'm dealing with pi over 12 as my segments, I'll increase on this side pi over 12, one of my segments. I'll add it again to get to 2 pi over 12, which is pi over 6. So I go 2 this way, and I'm going to go 2 to the left as well as my middle point, which is really like whatever my phase shift is. So negative pi over 12, subtract again, I'll get negative 2 pi over 12, which is negative pi over 6. So that means that these are my two my two asymptotes that I'm dealing with. Normal tangent looks like this. That means that negative tangent, when I reflect it, it looks like this. It looks like the cotangent graph. So I'll be going up however many units my amplitude is, which is 2. So I'll be going up 2 units and then down 2 units on either side of that middle point that I have at 0. And connecting those with my tangent graph or my reflected tangent graph. And again, my range here, since I'm going in both directions, it's negative infinity to infinity. Oops. Okay, last one. This one's a little bit harder because we actually have a phase shift here. So first thing I'm going to do is divide everything by 3. I'm going to pull out that b value that I'm going to deal with. So my amplitude in this case is 1, since I'm not dealing with anything in front of my tangent. My period in this case is pi over 3. Again, same as before, which means I'm going to be doing pi over 12 segments. I didn't really mean to have all of these be pi over 3, but that's how it worked out. My phase shift is to the right pi over 3 units. And my vertical shift is up 1. So I'm going to leave myself some room because I'm actually going to be writing out all my and how I'm going to find my critical values. But this is going to be like our center is like looking at that phase shift of pi over 3. And then we're going to go on both sides of pi over 3, adding our segment pi over 12 to that to get our third critical value, and then subtracting pi over 12 to get the other value on the other side. So we're starting at pi over 3, we're going up pi over 12 units, then we'll add another pi over 12 units to that, and then going backwards to the left, we'll subtract pi over 12, and we'll subtract pi over 12 again from that part. So I'm going to make this a little easier on myself. From now on, when I talk about those pi over 3, this is really 4 pi over 12. So I'll change that over here as well. Looking at pi over 4, or 4 pi over 12 is really pi over 3, since you divide the top and bottom by 4 and you get the same thing. So one of my critical values is going to be 5 over 12, 5 pi over 12, and then if I add that again, that pi over 12 to that critical value, I get 6 pi over 12, which is pi over 2. Five pi over 12 and pi over 2. Oops. Okay, over here, 4 pi over 12 minus pi over 12 is 3 pi over 12, which you could leave it like that, but that's actually pi over 4. So that's another critical value that we're going to put to the left of that. And then if I subtract pi over 12 again, I get 2 pi over 12, which is pi over 6. That's what I was going for, which is right here. Again, mine aren't that equally spaced in real life. I would like that to be a little bit better, but when I was drawing this, I didn't get that far. So again, we have this vertical shift of 1. Don't forget about that. We have our asymptotes at our first and fifth critical value. At pi over 3, this is our center point. So we'll plot our point there. And this is regular tangent graph, which means it's going to look something like that. Which means that at our first critical value to the left of our center point, we're going to go down our amplitude. So in this case, we're just going down 1 unit, since our amplitude is 1. So from our baseline, going down 1 unit. And then at 5 pi over 12, which is 1 to the right of our baseline, we're going up 1 unit, since our amplitude is 1. Then we connect that with our tangent graph. Again, our range is negative infinity to infinity, since we're going in both directions. And again, our domain isn't that. We'd have to restrict our domain. Okay, last part, and I would pay attention to this. It may or may not show up in your test tomorrow. Considering this function, d plus a sine b x minus c, and we're going to talk about what happens at these transformations. So what happens when a is negative? Well, if a is negative, that's the stuff that's out front in front of sine. This reflects our graph over our x-axis. So it'll flip it around, it'll reflect that. When b is greater than 1, so when our b value, if that's like 2 or 5 or 3, it makes our period shorter. So our period gets shorter or smaller since we're doing 2 pi over b. But when b is between 0 and 1, we're dividing by a fraction, which means our period is getting larger. And if d is negative, that's our vertical shift stuff. So if d is negative, then that moves our graph down. D units, whatever that is. So if it's negative 1, it moves it down 1. If it's negative 5, it moves it down 5 units. And the last one, what happens when c is positive? Well, c is getting subtracted in our fraction, or our parentheses. So if, let's say, c is positive like 4, that would move it to the right 4 units. So when c is positive, we're moving the graph to the right. Likewise, if c was negative, that would mean we were subtracting that, and it will show up as a positive on the inside. So if c were negative, we'd have sine of x minus negative 4, which would be sine of x plus 4, which would mean that it's going to the left that many units. Okay, I hope this was helpful. I'm going to post this as my answer key on Google Classroom 2, and I'll post the answer key to the in-class review that we were doing today, so you have that to reference. So if you can do all this, then you're pretty golden for the test tomorrow, except for I would still study writing the trig equations that go through those points. And I would look at some other varieties of these like tangent and cotangent graphs, since all of these dealt with like pi over 3 just coincidentally, and looking at that pi over 12 units. And so there's some harder ones looking at like example 3 in that in-class review. Since you're actually not that one. Looking at the extra practice one, there's some harder ones on there, so I would try those and see if you can come up with those right answers. Okay, see you tomorrow.